Hi, for this video what we're going to do is we're going to solve a system of three equations. When you start getting into systems of three equations, it does take a lot of keeping track of where you're at. Remember that you are going to be looking for three solutions. So in this one, we're going to start with one that's pretty basic. Like this is as easy as it gets with a system of three equations. And the reason it's a little bit easier is because we already have one equation that only has one variable. So anytime you're given something like this, that's where you want to start because it's an easy place to start to find a variable. After that, once you find your first variable, then you plug it in, and you have to solve a system of two equations. So it's something that you have to keep track of a lot of things. So let's start by solving this first equation, 9y equals negative 18. So we would end up with y equals negative 2. If I divide both sides by 9, I end up with my first answer, y equals negative 2. So with this, now what we would do is we would take this equation right here, the y equals negative 2, and we're going to plug it back into both of these equations. So when I do that, I'm left with negative 6x minus 4 times negative 2 minus 5z equals 0. So all I did was I replaced the y with what it was equal to, negative 2. And we're going to simplify this to where we have x and z on one side and our constant term on the other. So this really becomes negative 6x plus 8 minus 5z equals 0. So our next equation that we're going to work with is negative 6x minus 5z equals, and we're going to bring this 8 to the other side, negative 8. So we have one equation that we're going to need in order to solve the system of two equations. So we also have to do the same thing because I can't solve this alone. I can't solve this the way that it is because it still has two variables. So what we're going to do is we're now going to do the same thing with the second equation. So we're going to plug the negative 2 in for y here. So I would have 6x minus 5 times negative 2 plus 4z equals 20. So if we simplify, we have 6x plus 10 plus 4z equals 20. So we would subtract the 10 from both sides. So we would be left with 6x plus 4z equals 10. So what I'm going to do is now that I've simplified these two equations down to where I have two variables, I'm going to take this equation here, the negative 6x minus 5z equals negative 8. And I'm going to take this equation, the 6x plus 4z equals 10. And we're going to solve this as a system of two equations. You can use elimination or you can use substitution at this point. It's a lot easier to use elimination because if you look at this, I'm going to choose to eliminate the 6x and the negative 6x because they're already opposite signs. So if I add these together, they automatically cancel out. So on the next part, I would just add these two together and this would give me negative 1z equals 10 minus 8 is 2. So we end up with z equals negative 2. If I divide both sides by negative 1 or if I change the sides of both sides to get the z by itself. We're still not done. We've found two of our equations. Now we have to find, or two of our variables. Now we have to find our third variable. And so what I'm going to do is I'm going to pick one of these two equations. I'm going to pick this one right here only because of the fact that the coefficient on x is positive. So I would use 6x plus 4 times negative 2 equals 10. 6x minus 8 equals 10. And so then we would end up with 6x equals positive 18. Because if I move this negative 8 to the other side, it becomes a positive, and 10 plus 8 gives me 18. And we're left with x equals 3. So now we have our third answer. And so in most classes you will write this as an ordered triple where we would write it as x comma y comma z. So we would see that x is 3, y is -2, and z is -2. And it's always a good idea to go back and check. To check, you would just plug it back into here. So if I take and I replace the 3 in, I'm just going to show the work down here. So to check, if I plug it into the first equation, we have the -6x minus 4y minus 5z has to equal 0. So we would simply just place our values into there. So I would say -6 times 3 minus 4 times -2 minus 5 times -2. Does that give me 0? So if we look at this, we would have -18 plus 8 plus 10, and yes, indeed, that does give us 0 because 8 plus 10 is 18, and 18 minus 18 is 0. You have to check it in all 3 of the equations. So the second equation was the 6x minus 5y plus 4z equals 20. So we're going to see, is this true if I plug it in? So 6 times 3 minus 5 times -2 plus 4 times -2 equals 20. And we would have 18 plus 20, plus 10, which gives us 28, minus 8. So 28 minus 8 is 20. So we can see that this works when we plug it back into both of the original equations. And then the third equation, you can see that 9 times -2 is -18, so that does work in the third one as well. So we can say that we checked the third equation as well. This is something that can take a lot of practice to get comfortable with because it does take up a lot of paper. It also takes up, you kind of have to keep track of where you are and what you're plugging in. So I will do some other more difficult ones. If you have any questions, please let me know. As always, thanks for watching.